Hello students, welcome back to the Tantray physics classes. Today I have come up with new problem on electrodynamics. The problem is like this. A circular coil of 20 turns and radius 2 centimeters has a resistance of 4 pi ohms. The magnetic field B is equal to T square is perpendicular to the plane of the coil. Find the charge that flows through the coil from 0 to 2 seconds. That is the question. You have a coil, and through the coil passes the magnetic field perpendicular to the plane of the coil. But that magnetic field is time dependent. So there is a change in flux, magnetic flux. We have to find how much charge flows through the coil. There will be a current through the coil. And current will be passing for some time, and therefore in that time charge will flow, because flow of charge is current, right? So it's something like this, a coil here of many turns, of 20 turns, and this is a radius r, and we can substitute at the end 20 turns radius, n is equal to 20, and there's a magnetic field, maybe in, maybe out. Okay, let the magnetic field be out, O dots, passing through the plane of the coil, passing perpendicular to the plane of the coil. And this magnetic field is changing in time, it is this, right? So, if the magnetic field through this coil is changing in time, that will produce induced EMF in this coil. And that induced EMF will cause current to flow through this coil. When current flows, that means there is a charge flow. We have to find how much charge flows from 0 to 2 seconds. But here I want to tell you something more about when there is change in magnetic field here. The change in magnetic field produces basically electric field in circles, tangential electric field, circular electric field. And when we integrate that electric field over a closed path, that is induced EMF. So this is what you call as, basically this is Faraday's law. Induced EMF is equal to rate of change of magnetic flux, right? But basically, the induced EMF which is created by the change in magnetic flux, basically this change in magnetic flux produces electric field here, tangential electric field in circles. If we integrate this electric field over this closed path, that gives rise to the induced EMF. This is Faraday's law, this one. Correctly, Faraday's law, very correct. But this is also written as, if we integrate this electric field over a closed path, we get the same induced EMF. Complete law is this. This is Faraday's law. And when you put this is equal to this is something like Maxwell's law. Because this was Maxwell. E is equal to this is Maxwell. E is equal to this is Faraday. But this is equal to this, and E is also equal to this. Basically, the magnetic field variation creates electric field in circles. And if you integrate electric field over a closed path, that is equal to induced EMF. Whether you use this rule or this rule, you will get the same answer. Anyway, so first of all, let me tell you what is the flux here. Flux is equal to, okay, that is N times number of turns, pi r square, that is area, and magnetic field, B. This is the flux. Area into magnetic field is the flux, but N number of turns. So, differentiate both sides. Differentiate d phi by dt is equal to d by dt of N pi r square B, right? Now, d phi by dt is equal to N pi r square d by dt. Magnetic field का differentiation होगा, क्यों? Because magnetic field is a function of time. Others are constant, they will come out. So it is 2t square, right? So d phi by dt is equal to N times pi r square. It is 4t. That is the induced, that is the d phi by dt. But we know induced EMF is equal to d phi by dt. How much is the induced EMF now? How much is the induced EMF? Yes. induced EMF E equal to minus d phi by dt, that's equal to minus n pi r square t 4 times. Yes. Now how much is the current through the coil? Magnetic field increases out, it increases outwards, and current should be like this, so that current produces its own magnetic field inwards. Because outward field increases, the current is such as to oppose the change in increase in the magnetic field. Sorry. Okay, now how much is the current? How much is the current that is induced by resistance? That is 4n pi r square t divided by r. Now current is equal to, it is 4n pi r square t divided by, what is the resistance of the coil? That's 4 pi. 4 pi. It gets cancelled. So what's current? R square t. N times R square t. This is the current. But here current is varying in time. So in order to find the charge flowing through the circuit, you know Q is equal to current into time. That's the formula. But here current should be constant in time. Then we have a formula Q is equal to IT. But if current is not constant but depends on time, then this is not the formula that we can use. We have to use formula based on calculus. So how much is the charge that flows through this coil in the given time 0 to 2 seconds? So that is Q equal to integration I dt 0 to 2. That is the formula. When current is changing in time, you have to use this formula. If current is constant, then you have to use this formula. Right? So Q equal to 0 to 2, what is current? N R square T dt. Right? Now Q equal to charge that flows through the circuit in 2 seconds. N out, R square out, T ka integration hoga, that is T square by 2. 0 to 2. Because constants will come out. So what is Q? That is N R square by 2. So T ka value dj 2, that is 4 minus 0. 4 minus 2 square minus 0 square, that is 0. So it is Q equal to N R square by 2 into 4. That's 2 2s are 4. So how much is the charge? That's Q is equal to, okay, 2 times N R square. So substitute the values. 2 into, how much is the N? That is 20 turns. How much is R? That is 2 centimeters. That's 2 into 10 raised to power minus 2 square. Okay. Now Q equal to is 2 to 4 to 8, 2 to 4 to 8 to 16, 0 into 10 raised to power this minus 4. That's Q is equal to 16 into 10 raised to power minus 3. Q is equal to 16 millicoulomb. Answer. This is the charge that flows through the coil when magnetic field through this coil is a function of T, change with time, is P is equal to T square, and number of turns is 20. That's all. So what was the basic concept? The basic concept was you have a coil and through the coil there is a magnetic field. That magnetic field changes in time. That means through the coil there is a change in magnetic flux. That means there will be induced EMF in the coil, or you can alternately say there is a tangential electric field, And when you integrate that electric field over a closed path, that makes induced EMF. The induced EMF in the coil will produce current because the coil has some resistance, and that current is not constant. That current was function of time again. So we can't use the formula Q is equal to current into time. We have to use the formula Q is integration of current over time. So from 0 to 2, and finally we got the answer, 16 millicoulombs, because 10 is power minus 3. Thank you. Continue to watch my lecture series on the YouTube, and I'll be continuously delivering lectures online so that students get benefited. Thank you.